Hi guys, I'm going to teach you about this kind of an SAT problem. It has one sort of characteristic that happens a lot in these exponential equations, and so I want to give you some experience to help you to understand how to write the equation for this. This SAT problem says, in planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. If the present population of the city is 50,000, which of the following expressions represents the engineer's estimate of the population of the city T years from now? Now, what I want you to notice about all of the answer choices is that none of them just say something like A times B to the X, and that's been our experience. That 20 years changes a little bit how we think about the problem, and that's what I want to teach you right now. Pause the video right now, take a second, read back over the problem, and decide for yourself. Make a choice, make a commitment, make a prediction of which of these equations, which of these choices will be the right choice. Pause the video now. Okay, I'm going to go over a similar problem to help you to see which of these choices is the right choice. So here's my problem. I wrote this problem. A bacteria growing on the banana that I left in my classroom at East is growing according to the equation B of t is equal to 3 times 5 to the t over 7. Gross. We have already learned that the 3 in this equation represents the starting point. So we're going to say that 3 represents 3 square millimeters of area of the banana that had bacteria on it. And I was going to eat that. That was fine with 3 millimeters of bacteria. In this equation, the time is in days. We want to know, when will the bacteria have grown to cover 5 times what it was when I left? Now, I've chosen these numbers to help us to see something. And remember, this problem that we're trying to teach you about said that there was a decrease by 10% every 20 years. And so what I'm trying to get you to sort of see is when that multiplying factor, that was 10%, here we're doing 5 times as much, when that multiplying factor happens, how frequently. And so we're going to look at this to help us to understand how to deal with that kind of a situation. So here's what this equation looks like. I want to know, when will it cover 5 times what it was when I left? Well, when it started, my starting point, it was 3. We want to know, when will it be 5 times that? So what we really want to know is, when will it be 15? When will the bacteria be 15? And so I'm going to put 15 right here. I'm going to put 15 as the amount of bacteria. And then here's my modeling equation, 3 times 5 to the t over 7. And now I'm going to solve this equation to answer the question of, when will it be 5 times as much as when it started, 5 times the start. Now, the first thing that we learned how to do when we're solving these exponential equations, we know that we're going to be using a logarithm, but we first have to get this exponential part by itself. So I'm going to divide both sides by 3. This is multiplying by 3, and I want that to cancel out so that I can get that exponential 5 to the t over 7 by itself. So I have this. Now I'm going to use what I learned about changing this into logarithm form. And what I learned is that logarithms are the way that we solve for this exponent. So when I write my log, it's going to equal that exponent. And that's the first thing that I write when I write my logarithm equation. Then I just write the word log. Then I say, this is my base for my exponential. I put it down in the base of my logarithm, and I still have this other 5. Well, that other 5 only has one place to go. It goes right there. Now, we know that a calculator can't calculate this because it's a base 5, and calculators that we have only have base 10. So I'm going to change this using change of base. Now, what we remember about change of base is that it changes this one logarithm into a fraction. And the top number, the number that's up high, goes on the top of that fraction. This base down here is down low, and it goes down low in my fraction. So I just changed this log base 5 into something that only uses logs with a base of 10. Now, I can see here log of 5 over log of 5. Well, anything divided by itself, well, that's just going to be 1. I could type it into a calculator, but I promise you it would equal 1. And so now what I have is t over 7 is equal to 1. I'm almost done. I almost know how many days it will take before it is 5 times as much. I need to get that t by itself. So I'm going to go ahead and multiply that 7 on both sides so that I cancel this 7, and I find out that t equals, well, 7 times 1 is 7. So 7 days, a week, is how long it takes before my banana has 5 times as much bacteria on it. Gross, sitting in my classroom at East. So what we want to notice here is that after we did all of this solving, what we found out is that this factor, this times 5, and I chose that on purpose, this times 5 is the base of my exponent. It's what it's being multiplied by each time. It occurs every 7 days. So if I have something that is growing by this scale factor every 7 days, then I take that exponent and I say, well, it's t per 7. Now, we already now have what we need, our new information for how to solve an SAT problem like this. Let's go back to this SAT problem and let's see how what we just saw applies to this SAT problem. This says it decreases by 10%. So I already know that this is going to be my rate is going to be decreasing by 10%. And I'm going to write that as a decimal. So this is going to be my scale factor is going to be 1 minus 0.10. And so now automatically I'm going to start looking at my multiple choice, and I know, oh, it's got to be either C or D. It's not going to be A or B because this is going to be 0.9. Now, when we go back and we look at what we did here, this scale factor of 5 happened every 7 days. It took 7 days. And so here in our SAT problem, it says it will decrease by 10% every 20 years. So this is 90% of what it was per 20 years. So this is going to say that my correct choice for this SAT problem will be D. 50,000 times 0.9 to the t over 20. I'm going to have a Google form to test and see if you understand how to do this. So feel free to review this example as many times as you need, and then go and answer that Google form. That'll be your credit. That needs to be completed by Monday's class, Monday morning. Thanks.